systems of inequalities and graphing them. We're talking about systems of inequalities now. So when we talk about these systems of inequalities, what we're going to do is we're going to talk about, first off, basically how the solution changes when we go from one to two or more inequalities. Now, when we talked about inequalities, the solution was an area or a region on a graph that satisfies that inequality. Okay, so it could be any point in that region. Well, when it comes to a system, so two or more equations, the solution is going to be in the area that is satisfied by both. That is very important, both inequalities. Okay, so when you look at this graph that we have here, when we talk about this one, the first and foremost is we have the green line, which is satisfied here and down here. Okay, when we look at the blue line, that is satisfied in here and then also down here. So the area that is satisfied by both is down in this area over here. Okay, so any point in there would be a solution to that system of inequalities. So what we're going to do now is we are going to graph the system of inequalities. So starting off with, just like we did the other day, we've got y is equal or is greater than 3x plus or minus 1. Start off with your y-intercept, which is at -1. Right? From there, you're going to graph 3x, or sorry, 3, the slope 3, so up 3, 1, 2, 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Right? And from there, hopefully we can draw a line. Now, what kind of a line would you draw here? Well, you would draw a dotted line. Let's see if I can do one. So I'm going to try this one, see if this will work for us. See if I can get this to work today with some sort of a semblance of a line. Okay, so let's give it a try. So see if this will work. Oh, no, that's not going to work well. That's gross. Here's a dotted line. Kind of looks like this. Okay. Again, I do not have the best dotted line. I apologize. So from here, shading, as we talked about before. When we talk about shading for this one, again, we're talking about shading up. Okay, greater than symbol, you're shading up. So the area that we're going to shade up, all right, is going to be this area over here. Okay, so this area over here is going to be satisfied by both inequalities. Now, I suggest on your paper, you shade in very lightly. Shade in lightly, all right, to start off with. So you get something that looks a little bit like this. Okay, all right, so from there, let's talk about the second one. Y is less than or equal to -2x plus 4. So with this one, start at your y-intercept of 4. 1, 2, 3, 4. There you go. Slope of -2, that means -2, so down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Now with this being equal to, this is going to be now, we're talking about a solid line. Let's see if I can do one. Let me try a solid line on here and see how it works. So here, there we go, kind of. I'm trying to go this direction, up, something like that. That's still not great. Trying all this stuff out, guys, so trying to make this as best as possible. So it should probably be more like this. There we go. All right, so the next thing again, shaded down. So from that line, I'm going to draw down arrows. So I know section that is satisfied by this one, as I'm looking at it, is going to be down here. Okay, now here's the question. This area over here, and then this area in here. So which area is shaded by both? That is the key part. The area that's shaded by both is this one in here. Okay, that is important to see. Okay. So if I'm looking at this, if I want to pick a point in that area, right, and I'm looking at this, say for example the point, I'll make it easy. Well, let's make it really easy. Let's do the origin. So if we look at the origin, that's 0, 0. By what this says, it should be a solution for both inequalities. So if we plug that in, obviously 0 greater than 3 times 0 is equal to negative 1. That's 0, so you get 0 is greater than negative 1. That's true. Plug in 0 for y, less than or equal to negative 2 times 0 plus 4. Well, negative 2 times 0 is 0, and 0 is definitely going to be less than or equal to 4. So that is a solution to both. Okay? If you pick points, say up here at 1, 8, not a solution to the system. It only satisfies the first equation. It doesn't satisfy the second one. Pick a point down here at say 2, 5, or negative 5, sorry. Not a solution. The reason why is it only satisfies the second equation, not the first. Alright, so let's try another one. So we got y is greater than negative 4 plus 5 over 2x. Now, as you can tell here, one of the reasons why I do this, when you're looking at this, the first inequality is just written in the wrong form. Okay? Your y-intercept for this one is still going to be negative 4. So you're going to start at 0, negative 4. You're going to use a slope of 5 over 2, so you're going to go up 5 units to the right 2. Up 5 to the right 2. Okay? And then from this one, with just a greater than symbol, you're going to draw a dotted line. Okay? There we go. That's kind of a dotted line. That might be better if I start doing this freehand. Alright, so from there, greater than symbol tells you you're going to shade up. So I'm drawing up arrows. And I know that at this point, I am going to shade up. So it's all this area in here. Alright, there you go. Okay. Alright. Next. Y is greater than 1/3 x. Well, there's nothing added on, so your y-intercept is at 0. Slope of 1/3 means up 1 to the right 3. Up 1 to the right 3. Up 1 to the right 3. And again, if you want to draw more lines, go down 1 to the right or left 3. Down 1 to the left 3 will give you more points. Again, it's going to be dotted. Alright, so we have a line that looks a little bit like this. Okay, and from here, when we look at this, we are going to shade up. So drawing up arrows, you're going to come from here, you're going to shade this direction. So everything's shaded up. Okay, so the only area that is shaded by both will be this area in here. Okay, now do remember, when we talk about just the greater than symbol, points on that line are not part of the solution. All right, so points on this green line are not going to be a solution, nor on the red. All right, so remember that clearly. All right, next one. Y is less than or equal to 2x plus 3. Let's graph that one. So starting off with, we are going to start at y-intercept of 3, slope of 2 means up 2 to the right one, up 2 to the right one, up 2 to the right one. Okay. The less than or equal to part, the equal to part tells you you're going to have a solid line. Okay. Let's draw a solid line. All right. All right. And then probably move that a little bit, not that. I can move the line. Make it a little bit better. No, that's a little bit off. Trying hard, guys. Sorry. I might actually erase it and just go do it over. Alright, so taking a look, starting off y-intercept of 3, up 2 to the right one, up 2 to the right one. So this is one of those opportunities, again, didn't draw it very well. Half the reason, didn't have very many points. Drawing more points makes things way easier to draw. As you can tell, it's almost a straight line. Alright, now which way do we shade? Less than symbol, shade down. So as we did before, everything on this side of the line, down. Alright, so from there, let's go back. And now we're going to graph the next one. Negative 6x plus 3y is greater than or equal to negative 15. As you can tell, we have an issue. It's not in slope-intercept form, so let's put it in slope-intercept form. So we're going to first get rid of the negative 6x by adding its opposite. Negative 6x plus 6x is 0. That's how we get rid of it. So now we have 3y on the left, greater than or equal to. We're always going to write the slope first, so 6x and then minus 15. From here, to get y by itself, we're going to divide both sides by that coefficient 3. 3 divided by 3 gives you just 1y, greater than or equal to. At this point, 6x divided by 3 is 2x. Negative 15 divided by 3 is negative 5. So I'm going to start at a y-intercept of negative 5. Slope of 2 means up 2 to the right one. Up 2 to the right one. Up 2 to the right one. Okay? Now, something I want you to notice, hopefully here, you're going to notice pretty quickly. So we draw those points on there. All right? We have a equal to part, so we have a solid line. Now, for this one, we're going to shade up, 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 up. Now, with this in mind, that means that we are talking about everything inside of this area. Now, a couple things for you guys to have noticed. First and foremost, the two lines, same slope, different y-intercept. So that makes them, yes, parallel. Parallel lines will not intersect. So, when you stated the area inside these two channels is basically what it is. That is the solution, right? If I asked you what the solution was to the equation, you would say no solution because these two lines won't intersect. But we're not talking about equations here. Now we're talking about an inequality. So anywhere inside that region is a solution. All right? So try this one. So these should not be too tough. Shouldn't have too much of a problem with this one. Again, though, when we talked about this, I do want to make sure that you guys remember we are talking about special cases. So for example, y is greater than or equal to 5. Well, y is equal to any number is just going to be a horizontal line because the slope here is 0 because there is no x. If there's no x, that means the m has to be 0. This is going to be a, there we go, flattest line you can have, slope of 0. So you got a horizontal line. Now, finding how to shade this is not hard. Shading one of these is pretty easy for you guys because shading up is not a hard thing to figure out. So we're shading up. Okay. So next, we'll look at this next one. X is greater than 2. Or sorry, less than 2. I apologize. Sorry. Less than 2. So with this one, let's take a look. We're going to do, we're going to draw a dotted line, a vertical dotted line here where x is 2. Something we've also discussed already. Now, with that in mind, we also talked about, well, you can't shade left or right, or sorry, up or down on this one, so we got to talk about left or right. We want all x values that are less than 2, so that's anything to the left. So that includes all of this area here. Now, that also includes what's up in here. So what that means is that the solution to the system, sorry, this is a little off, will be anything inside of that quadrant there. Okay? All right. So I think that was about it. Nope, we're going to recap, sorry. One more. So let's talk about this one. Now, when we talk about a problem like this, what we're going to talk about is how we write this equation. Now, Thomas needs pencils and notebooks for school. Pencils are $1.50 and notebooks are $3. He has $15. How much can he spend on pencils and notebooks? Well, starting off with, as we've talked about before, anytime we do this, you need to identify your unknowns. For this problem, this kind of helps you out a little bit, but the two things you don't know, again, in the question, all right, number of pencils, I'm going to make that x, all right, and then y is going to be the number of notebooks. Now, with that in mind, starting off with a couple things that we have to realize here. One, you got to have pencils and notebooks. So first and foremost, you have to have an x, in other words, that's going to be greater than or equal to 0. So starting off with in a problem like this, we know for this one, you've got to have an x that's going to be greater than or equal to 0. So in other words, you're going to have something that goes up this way. Okay? That's first and foremost. Because you got to have pencils. Second, when we look at this, you've got to have notebooks. So we need y's that are going to be greater than, right, or equal to 0. Oops. Probably should have done that with a blue, huh? Let's get rid of that one for you. We'll try it again. Might even draw this one just for the heck of it. There we go. Okay. So we know we have to have notebooks, so we need something greater than that. You can't have a negative number of notebooks. Okay. So we know we're going to have something in those areas. Now both of these are greater than or equal to. So that means we're going to have everything in the first quadrant. So from there, as we talked about before, if you're writing the inequality, and we're looking at something like this, pencils are $1.50, notebooks cost $3. So $1.50 times the number of pencils plus $3 times the number of notebooks has to be $15 or what? Can you have more than that or you have less? Well, think about it. You can really have just less than or equal to. You can only spend up to $15. Now, as we look at something like that, we need to graph that. Now, I've already put the graph on there, but how would you do that on your own? Well, you got 1.5x plus 3y is less than or equal to 15. Put it in slope-intercept form. So, from here, at negative 1.5x, and we'll talk about that here in a moment. Negative 1.5x, right, to both sides. So we get 3y is equal to, in this case, negative 1.5x, and plus 15. Divide both sides by 3. Right? So from there you get y is equal to negative 1/2 x plus 5. You see we have a y-intercept of 5. We went down 1 to the right 2 for each one of those. No, I'm sorry. And then from there, and I apologize, these are less than or equal to. Which way would you shade? Well, the only way you'd shade it in this one, you have to shade down. We're going to have this whole area in here. If I can get it. It's not working. There we go. A little slow today. There we go. So, you can pick any point in there and you'll stay under the $15 that you have. That's what this problem talks about. So for example, let's say I picked a point, oh, I don't know, 3.2. That's the point 3.2. Now, what does that mean? It means 3 pencils, 2 notebooks. Well, 3 pencils, that's $1.50 a piece, so that's going to be $4.50. How many notebooks? 2 notebooks, that's 2 times 3, that's $6. So $4.50 plus 6 gives you $10.50. Right? So that saves another $15 you want. Now, something that's very important about this. Any point on this line that gives you an integer, you're going to notice will be exactly $15. For example, the point 0.5. That's 0 pencils and 5 notebooks. Well, 5 notebooks times $3 is $15. Okay? Just some things for you guys to notice. Okay? All right, ladies and gentlemen. So, you guys have an assignment on graphing a system of inequalities. All right, work on that. If you got any questions, let me know.